Hey you guys, okay, so we are not at school today, but we are still having a school day. So I wanted to start off with going over your homework. Your homework was on page 88. You had to do number 18. Number 18 says, what information do you need to know to prove that line M is perpendicular bisector of AC? Well, you would need to know 18 over here. 18, you would need to know that B is the midpoint of segment AC and that M is perpendicular to AC. Number 19, given that line M is perpendicular to AC, AB equals 4x, a perpendicular bisector of AC. AB is 4x minus 1 and BC is 2x plus 7. So they're telling us that's the case. They also told us that this is a bisector, so B is the midpoint. So you know that AC is going to be cut in half, which means that we can just simply set these two things equal to each other and solve. So you would solve that out just like algebra 1, and it tells us that x equals 4. Okay, let me go back up to the top of this page. At the top of the page, number 20, it says based on your answer to item 19, what is AC? So that would be in the entire thing. We got that a piece of it is 4, so the entire thing is 30. Oh, I was like, how? How did they get that? We got that x equals 4. So let me scroll back down. So what we would have to do is take that x equals 4, plug that in. So 4 times 8, not 8, I'm sorry, 4. 4 times 4, because x equals 4 minus 1, that's going to be 16 minus 1, which gives us 15. So if this piece is 15, this piece is 15, so the entire thing is 30. That's why it was D. Okay, then number 21. If we look at 21, it says how many lines perpendicular to line L can you draw through point M? Well, only one. That's the first thing that we talked about in the previous lesson. That's the perpendicular postulate. Number 22 is the proof. We have a theorem. If two lines in the same plane are perpendicular to the same line, then the two lines are parallel to each other. That's kind of like the example that we talked about. So then you are filling this in. Here is the correct answers. The first thing, you just write out the given. You know that angle 2 is a right angle and angle 6 is a right angle. That's the definition of perpendicular lines. 2 and 6 are congruent because of the congruency theorem, the right angle congruency theorem. Therefore, that you know lines L is parallel to line M because of the converse of the alternate interior angles theorem. So you know that 2 and 6 are going to be alternate interior. So since those are alternate interior, they are using the converse of that. So instead of it being two lines are parallel, we're saying if the two alternate interior angles are right angles, then the lines are parallel. So that's why we're using the converse. We're just switching around, going backwards. Okay, so that was that. Now, for today's lesson, we are moving on to lesson 8.1, which is on page 89. So just that next page. And we are going to be talking about the slopes of parallel and perpendicular lines. Hopefully this lesson is really just a review for you, because really if you paid any attention in your middle schools, then you would know the rules about parallel and perpendicular lines. But we are going to go back over it because Springboard has it in this lesson. So our learning target for today says make conjectures about the slopes of parallel and perpendicular lines, and then use slope to determine whether lines are parallel or perpendicular. All right, we are going to skip this front page. We're not going to be talking about that. So we're going to this next page here. And we're going to look at number 2 is where we are going to start. Oh, I'm still in my teacher book. That's going to be confusing to you. Sorry. Let me switch to my student book. I was wondering why there was so much writing on there. Okay, good. So it says, recall that the slope of a line is a ratio of the vertical change to the horizontal change between 2 points. If x1, y1 and x2, y2 are points on a line and the slope is given by m, explain why the slope can be calculated using the equation y2 minus y1 all over x2 minus x1. We are looking for the change. We are looking for the change. Well, that's not wanting to write. Okay, there's that. Sorry, let me try this one more time. We are looking for the vertical change over the horizontal change. Okay, so we're looking for that vertical change over the horizontal change. That's why that equation represents our slope. Now, if you look at this situation that we've got right here, I don't know what that represents. Kind of looks like a roller coaster to me. Oh, it represents the skateboard ramp. Okay, so they want us to calculate some slopes. So we're going to practice that. If we are calculating the slope of WV. So W is here, V is there. So we are going to do rise over run. Now, we could also do the y2 minus y1, but with something like this, it's really easy for us just to count. The rise is 1, the run is 3, so 1/3. Okay, then we're looking at V to U. So again, 1/3. So it says explain why the slopes of both of those segments are equivalent to xt. So if we did x to t, x has got, well, that's actually kind of not in a great spot, so we can't really count that one out. But how do we know that they are going to be the same without even looking at the slope? Well, they're on the same line. Okay, so each of those segments is on the same line. That entire line is going to have a slope of 1/3. Okay, then it asks you to find the slope of all of these different segments. I'm going to give you a second. I'm going to pause myself to give you a second to do that. Okay, if you need more time, just hit pause on your video so that you can finish that out without me giving the answers away to you. The first one is positive 1/3. The second one, B, is 1/3. The third one is -3 or -3/1. TJ is -3 and AD is 0. Remember, anything that is a flat line is going to be 0. Anything that is a vertical line is going to be undefined. All right, so we're going to look at the table on the next page. So over to that next page, and they're wanting you to fill that chart in with pairs that are either parallel or perpendicular. So again, pause the video so that you can fill that in. I'm going to go ahead and keep going, but again, pause the video if you need more time. So this one, the first set are going to be parallel. Their slopes are both 1/3. This one, these are both parallel. Their slopes are both -3. The next set is perpendicular. Their slopes are negative 1/3. No. Positive 1/3, my bad. Positive 1/3. And the other one is negative 3. One positive, one negative. The next one is again perpendicular. Same thing, positive 1/3, negative 3. And then these are both neither. If you looked at those, you would have seen they are neither parallel or perpendicular. This one's just 1/3 compared to 0, and then this one is 3 compared to 0. So that doesn't have a relationship that's parallel or perpendicular. So they want us to write the rules on number 6. So if you have parallel segments, they have the same slope. Parallel are going to have the same exact slope. If they are perpendicular, they have the opposite. So if one's positive, the other has to be negative, or vice versa. And then they are the reciprocal, okay? They are the opposite reciprocals, which basically means that if one of them is 3/4, the other one has to be negative 4/3. Okay, if one of them is negative 2, the other one is positive 1/2. If you have a whole number or an integer, you can always put that over 1 so that you can make the swap, so that you can see your perpendicular slopes. Okay, if the segments are neither parallel or perpendicular, then there's just no relationship. Their slopes have no relationship to one another. They're just different. Okay, let's finish this up by check our understanding. Very short lesson today. So number 7, do the conjectures you wrote in item 6 apply to lines as well as segments? Okay, is it just segments or is it both, lines and segments? The answer is yes, it is lines and segments. Okay, they have the same characteristics. A segment is part of a line, so a segment has the same slope as a line of which it is a part of. So that's definitely going to be the case. Number 8, are all horizontal lines parallel? Use slope to explain how you know. So yes, all horizontal lines have a slope of what? That's correct. 0. I know you said that from your bedroom. Line JK has a slope of 2/5. Lines MN has a slope of 5/2. Are these segments parallel, perpendicular, or neither? Well, they are the reciprocal of one another, but they are not the opposite reciprocal, so they are neither. Okay, this is your homework. If you get that finished and submitted to me, that is all you need to do for the day. You guys enjoy the rest of your day, and I will see you sometimes later this week. Bye. Let that pause.